Fill in the blanks with appropriate word. The region in a sound wave with higher pressure and density is called dash, and that with low pressure and density is called dash. Compression, rarefaction. Medium is dash for generation of sound. Needed in bracket or necessary. The total number of compressions and rarefactions produced per second in a sound wave is 1000. The frequency of the sound wave is dash. 500 Hz. Different sound notes have different dash. Frequencies. In loudspeaker, dash energy is converted into dash energy. Mechanical sound. Give scientific reasons. It is essential to change the tension on the vocal cords as we produce different sound notes from our larynx. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for the passage of air. When the lungs force air through the slit, the vocal cords vibrates, producing sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different. Astronauts on the moon cannot hear each other directly. The moon does not have atmosphere. Since there is no medium which is necessary for generation and propagation of sound between the astronauts, direct sound propagation between them is not possible. Hence, two astronauts on the moon talking to each other directly will be unable to listen to each other. As the sound wave propagates from one place to the other in air, the air itself is not required to move from one place to the other. When sound is produced, it transfers in the form of vibrations. Vibration produces energy which gets transferred from one particle to another form of alternative compression and rarefaction. Since there is only transfer of energy and not transfer of matter, particles only vibrate about fixed position but do not move. Hence, air itself is not required to move from one place to other. Or different sound notes generated in musical instruments like guitar, which uses strings for sound generation, and flute, which uses blown air for sound generation. Instruments like sitar, violin, guitar, which use strings for production of sound, and instruments like flute, shehnai, which use air blown into pipes for the production of sound. In string-based instruments, the frequency of vibration of the string is changed by changing the tension on the string and or by changing the vibrating length of the string using fingers. This results in generation of different notes. In musical instruments like flute, the holes on the flute are opened or closed to change the length of vibrating hair column in the flute. The frequency of waves therefore changes and it results in the production of different notes. In flute, different notes can be generated by changing the way of air blowing also. How is sound produced in a human larynx and a loudspeaker? Sound production in larynx. In the humans, sound is produced in the larynx. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for the passage of air. When the lungs force air through the slit, the vocal cord vibrates, producing sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different. Sound production in loudspeaker. The internal arrangement in the loudspeaker consists of a permanent magnet. A coil is wound around it, and if a current flows through this coil, it also generates magnetic field. If two magnets are brought near each other, they move depending on their positions. In the same way, depending on the magnetic field created due to coil, the coil moves back and forth. The frequency and amplitude of the movement of the coil depends on the variation in the current flowing through the coil. As the coil moves, the conical screen of loudspeaker, which is attached to the coil, also moves back and forth, and sound waves are produced in air. Explain the experiment with need diagram to prove the following. Sound needs material medium for propagation. In this experiment, a vacuum tight bell jar is placed on a smooth horizontal surface. The bell jar is connected to a vacuum pump via a tube. We can remove air inside the bell jar using the vacuum pump. As shown in the figure, the bell jar contains an electric bell which is connected to the power supply through the lid of the bell jar. At the start of experiment, The vacuum pump is off and the bell jar contains air. If the key to electric bell is now switched on, the bell starts ringing and the ringing can be heard from outside the bell jar. Now, if the vacuum pump is switched on, it starts removing the air from the bell jar. As the quantity of air inside the bell jar decreases, the level of ringing sound heard outside also decreases. If the pump is operated for sufficiently long period, the quantity of air like inside the bell jar will be low. At this point, the level of ringing sound will also be very low. This experiment demonstrates that sound generation and propagation needs a medium. Match the following: human larynx, vibration in vocal cords, loudspeaker, vibrations of screen, jal tarang, vibrations in air column, tuning fork, vibrations of metal arms, sitar, vibrations in strings.